Sebastian from Group 7, and today we'll be doing the experiment 5, which will be climbing film evaporator. So a climbing film evaporator is used to remove vapor so that you can have a higher concentration. And it is normally used when we want to evaporate heat-sensitive products such as pharmaceutical products, milk, or nutrients. This is so in order so that we can preserve its nutritional contents without it having any bacteria. So industries often use climbing film evaporator because 1. It has a high heat transfer coefficient H, and 2. It has a short residence time, meaning it does not need to stay inside the reactor for a long time. It can operate under batch or continuous. So we try to achieve 2 objectives for this experiment. The first objective was to study the influence of vacuum levels on evaporation rate. The vacuum levels that we studied was at ATM, minus 200 mmHg, 400, 600, and 700. And the second objective was to study the influence of feed flow rate on different heights, which was 25 cm, 50 cm, 75 cm, and 100 cm. And now I'll briefly introduce the apparatus inside this experiment. So we will have a feed tank here, and this will be the evaporator, which has a steam entry here and a steam outlet at the top. And at the top part, we have a cyclone and a concentrate tank, a condenser with 2 condensate tanks. And that's all for the apparatus that we will be using for this experiment.
Hi, my name is SAFURA 21361. Currently, I will explain about the methodology of this experiment. We are conducting the climb film evaporator. Basically, in this feed tank, we use potassium manganate solution. For the first experiment, we are studying the effect of feed level of this evaporator. First, we need to open the valve V2, V3, and V5 to allow the feed tank into this evaporator. Next, we need to close the first valve and open the steam valve to allow the hot water into this evaporator. After that, we need to observe the first and the second bubble form, and we need to take the time taken. After that, we need to wait until 20 minutes to collect the sample of concentrate, condensate, and evaporate. We need to measure the refractive index and as well as the volume of the solution. After that, we need to return back all the sample into this feed tank, and we repeat the same step for 50 cm, 75 cm, and as well as 10 cm. This is for the first experiment. For the second experiment, we study the effect of the pressure in this evaporator. We need to open the valve V2, V3, as well as V5 to allow the feed tank into this in this evaporator until it was 25 cm height. We need to keep this constant for all different pressure, and then we need to open the push valve. So we need to close the push valve and close and open the pressure valve simultaneously to allow the hot water to be in this evaporator. We need to observe the first and second time taken for the bubble form, and then we need to take the sample of the concentrate, condensate, and as well as evaporate, and then we need to measure the volume as well as refractive index, and we have to return all the sample into the feed tank. Next, we use the same step with the different pressure. We need to for different pressure. For example, we use negative 200 millimeter mercury. We need to open this valve, and we need to see it achieves until negative 200 millimeter mercury, and then we need to close when it achieves negative 200 millimeter per mercury. And then we need to observe the first and second bubble form, and then we need to wait until 20 minutes to take the same the sample of concentrate, condensate, as well as evaporate. And we use the same method we need to calculate the reparative index as well as the volume of the sample, and we need to put back it in this lead time. We use the same procedure for the negative 400, negative 600, as well as negative 700 millimeter mercury for pressure for this experiment.
ZAINAL ABIDIN with matrix ID 21344. So I would like to continue about the results and discussion for our experiment. Today I would like to talk about the first experiment, which is the effects on evaporator feed level. And in this experiment we have constant pressure, which is 1 atm. So in this experiment we increase the feed level, which is the potassium permanganate solution, from 25, 50, 70 and 100 centimeter, which means the height of the column. So from this table we can see that when we increase the feed level from 25 to 100 centimeter, the time for the first bubble will decrease, and also the time to boil also will decrease. This is because when we increase the feed level, means that we increase the height of the column. So when the height of the column is increases, the area also increases. So when area is increases, more steam is supplied to the solution, and this makes it faster to boil. So to conclude from this, the higher the feed level of the solution, the faster it takes for the solution to boil in the evaporator column. Okay. Next, in terms of the volume of evaporate, concentrate and condensate, the higher the feed level, the higher the volume of evaporate and concentrate. Since the feed level is higher, more solution is retained inside the evaporator column, so more liquid is vaporized. Means liquid turns into vapor. So in terms of concentration, the higher the feed level, the lower the concentration of product of evaporate, condensate and concentrate, which means that as the solution exposed to heat during the evaporation, more water is vaporized, and this means that more molecules of water are converted into vapor. So the evaporate concentration will tend to decrease. So from this graph, we can see that the graph feed level against time taken, which means I extracted from this table. When we increase the height of the column or the feed level potassium permanganate solution, the time taken will decrease, which is the time taken for the solution to boil. So that's all. Thank you.
A very good morning. I am SHARVINRAJ from Group 7. Today we are going to see what is the effect of pressure in climbing film evaporator. From the experiment 2, we can find out how the evaporator pressure in climbing film evaporator can affect the process and also the product. From the experiment, as the pressure decreases, the time taken for the first bubble to form also becoming very less. This is because higher the pressure, the shorter the time taken for the KM to boil. And this is happening because the pressure acting on the liquid, and it requires lesser time and energy to make the vapor pressure equivalent to the atmospheric pressure. From this experiment, we can conclude 3 graphs. The first one will be a time versus pressure. As we all know, higher the pressure, the lesser the time taken for the vapor pressure to be equivalent as the atmospheric pressure. The second graph will be volume versus pressure. As the pressure decreases, the total volume of the product also decreases. When the pressure decreases, water molecules easily escape to higher rate of evaporation, and at this place the vapor will flow to the condensate and concentrate, increasing the product volume. Okay. For the third graph, it is concentration versus pressure. As the pressure decreases, the concentration of the product also decreases. As more water molecules is converted to vapor, and the concentration and also the condensate also decreases. And that's all for the results for part 2, the effects of pressure on climbing film evaporator. Thanks.
Hello everyone, I'm SHASYA and I'm going to conclude about this experiment. We want to achieve two objectives for this experiment. Firstly, we want to investigate the effect of evaporator feed level, and the second objective is we want to study the effect of evaporator pressure. So, to achieve both objectives for this experiment, we have to measure the refractive index and the volume of every product for concentrate, condensate and evaporate. Next, we have to record the time taken for the first bubble to form, and also we have to record the time taken for the solution to boil. Now I'll move to the result that has been made. Based on the result, the feed level increased while the time taken for the potassium manganate to boil decreases. This is due to the increment of total surface area of the volume that increases exposure to the steam. As more solution exposed to the heating during evaporation, more water molecules will convert to vapor, which will send as product of condensate and concentrate. The second objective, as the pressure of the evaporator increase, the time taken for the potassium manganate to boil also will decrease. This happens because less heat energy needed as the water molecule particles become easier to escape. Lastly, when the rate of evaporation becomes higher, more vapor will produce. Therefore, the solution in the evaporator will decrease. The vapor produced will turn into condensate and concentrate, so that the product volume will increase. That's all from